FET. Okay, that is the reason why they have chosen this carbon nanotube as a technology to fabricate your FET. The advantage of on-current performance is due to the high gate capacitance or improved channel support. Okay, so as the diameter increases, the switching speed increases and device gets saturated faster. So it is going to be carbon nanotube is a rolled structure, right? So if the diameter is going to be larger and larger, they can say the switching speed will increase and the device will get turned on or turned off faster. So the diameter with the drain current will increase the diameter, and its difference decreases as the diameter go higher and higher. So drain current is dependent on the diameter of your CNT. So the improved channel, since the channel is conventionally the channel is made up of silicon, but now the channel is made up of carbon nanotube, right? So because of that, it devices improved mobility and band gap structure. So it reduces power consumption. It has a very high gain. It is stable and can be easily implemented in logic circuits. So these are some of the good advantages of CNT FET. So you know that the size of the CNT is 10 power minus 9 nano. So the operating frequency will be in the higher order of gigahertz and terahertz regime. You can use this CNT FET where conventional semiconductors will fail to operate. So size Korea, the operating frequency will be larger and larger. Okay, the larger it will be larger and larger. So I can say the CNT FET is going to be used in nano gigahertz and terahertz